Okay, so let's start with the presentation about IoT at home. Yeah, next slide. Who am I? My name is Jeroen Reinenbergh. If you want to know something more about me, my website is on the slide. It's hosted on a Raspberry Pi, by the way. What have I done up until now in my life? I graduated in business and IT. I have a master's degree in both management information systems and computer science, so I know a bit about the technical stuff, but also about the business stuff. After I graduated my last master, I decided to go work at Exellys. There I started as a test engineer at Swift. After that, I was an AI engineer at ING. And finally, I worked as a software developer at Dela Private Bank in Antwerp. That was it for my Exellys career. I recently decided, or at Exellys actually, I also gave IoT workshops, and it's there that I got the idea to start up my own company. I think that's the next one. Yeah. So I founded Techexplore. That's the name of my company. What does it do? Well, it's the goal of the company is to provide people who are interested in IT with the necessary tools and workshops to actually learn IT and get to know the basics of it, so that people can learn it in a very accessible way. Unfortunately, this year Corona was also there, so workshops was not really the right thing to do in 2020. But well, we'll see what we can do next year for my company. Furthermore, I also decided to make a radical career switch. I changed from IT consultant to lecturer. So now I give lectures at the Karel de Grote Hogeschool. That's a high school in Belgium, in the IoT graduate program. That's where I am now, actually. So I'm in the lab where, well, there's no students now, but they've gone to lunch. But that's what I said earlier. You might hear some drillings and drilling sounds and some hammering in the background, and that's students working on their electricity projects in the back. The doors are closed, but you might still hear something. And that's it about me. Now, what am I going to discuss during the presentation? Oh, something I forgot to mention. If you have questions, please do ask them in the chat. I will try to monitor the chat once in a while and answer those questions within the time of the presentation. So please do ask your questions. I love answering questions. So please do. What are we gonna talk about during the presentation? We'll talk about hardware. So the buy versus build question: is it better to buy or to build your own IoT system? What different type of controllers are out there? Which kind of I/O components can you use for your IoT projects? Then software-wise, which programming languages can you best use? In which environments do you use them? Network technologies will also be discussed. And then the most interesting part, sorry. So yeah, this is the first time I do the presentation in English. It's a bit weird for me as well, but I can manage. So which projects have I built before? I'm going to quickly go through 3 to 4 projects that I have built that might seem interesting to you guys. I've also done some research, and I've come up with a few use cases that you can implement yourself at home. Some basic projects with a big return on investment. And then I will also get you started on learning the right technologies, using the right tools, buying the right stuff to get you started as quick as possible. And then finally, there's a Q&A session with general questions about the presentation if you have not sent them in the chat by then. And also, and I really do hope there will be a lot of response for that topic, technical project queries. So I hope you guys have some ideas in your mind about IoT projects. So I hope you do ask a question about that. For example, I would like to build this project, but what exactly do I need from a technical point of view? What hardware should I buy? Which programs should I install on it? What language should I use to program, etc., etc. So that will be the fun part. Okay, let's start. The hardware. So on the one side, you see some components that look quite beautifully. On the other side, some other beautiful components, but a bit more raw, or should I say, yeah, a bit less beautiful maybe. So the difference between the two is rather obvious. So the left components on the left side you can just buy in the store. Components on the right side you could also buy in the store, but my experience is that in Belgium I did not find a single store where I can buy a Raspberry Pi physically. I have to order it online, and mostly it's from a Dutch website. So you guys are in luck. You seem to be the concentration points of IoT controllers near Belgium. So this is the big buy versus build question. And what are the advantages and what are the biggest advantages and disadvantages about this? Well, if you buy it, it's just a plug-and-play solution. Vodafone in Groningen is a nice store to buy electronics. Okay, if I ever go to Groningen, I will pass by the store. So
Thanks for the tip. Nice to share. If you have things to share, do it. It's also nice for
us. So for the buy side, it's a plug-and-play solution. So you just plug it in and it works. So that's a big advantage. It's an all-round solution, so that means that if you have a problem, you will always find a solution for it. If you look online, you can always just buy something that remedies your problem. On the other side, the big disadvantage is that often you do have a vendor lock-in. And what do I mean by that? Just an example, I don't mean to offend the producer that I mentioned now. So imagine that you have Philips light bulbs and you want to connect it to your, what else do you have? Somfy sunscreen. Do they call it sunscreen? The things that go down when the sun is too bright on your windows. Imagine that you want to connect those two. Blind. Yes, thank you, Max. Imagine that you want to connect those two. Now, for this example, those are two relatively popular brands. So I'm quite positive that it will work. But if you have less popular brands, they don't have all the connections that you want with other brands. They don't have open protocols. They don't have a lot of stuff that is needed to connect the two together. Mostly, they only provide connections between components of their own brand, and that's a big disadvantage for me because if you want to IoT your home, you want to connect everything and not just closed off islands of connected stuff. Next, the build part. So that's when you build your own solution, it is highly customizable. You are the one in control. So you decide what goes in, what goes out, which requirements you address, etc. It is cheap, or at least it is cheaper than the left part of this slide, because, well, Raspberry Pi it is cheap for what it can do, but it's not that cheap. As for the other controllers, it goes the same. You have cheap controllers, you have extremely cheap controllers, especially if you go to Chinese websites for those. You also have expensive controllers. They're still cheaper than if you then in the situation where you would buy the controller that was wrapped in a nice package embedded in an electronics or a consumer product if you buy it right from the store. So it is still the cheaper solution to build your own solution, and it's fun. It's just fun to do. Even if I would have all the money in the world, I would still build my own IoT solutions just because I like doing it. You learn a lot by doing it. You fail a lot, but the more you fail, the more you learn, they say. That's our motto at KDG. But enough about that. What I want to ask you guys is, what do you feel about this dilemma? Would you rather buy your own IoT solution if you had money? So assuming you just won the lottery, would you buy your own IoT solution or would you build it? So there's a QR code in the left upper corner. Buy. Okay. So can I see how many?
That's me.
That's you. Okay. Is it just because you don't have a technical background, Penny? Or
Yes, because I can't do it, Jeroen.
Okay, but now build is winning. Okay, so we have a lot of techies here who like to build stuff even if they have the money to buy it. That's nice. Okay, so a lot of like-minded people here. That's nice. Of course, there's nothing wrong with buying it. I would probably buy my own stuff, some stuff, but not all of it. So next, next controllers. So I mentioned before that you can build your own solution.
Jeroen, Chris is saying already have some assistant running, and I do what to connect all the things.
Home
and
assistant.
I do want to connect all the things. Sorry, I do want to connect all the things.
So yeah, I know Home Assistant. That's an application to indeed to connect your home appliances in an IoT kind of way, and I do want to connect all the things. So that's you can do that indeed, but the things that you want to connect have to be open for it, so to speak. It sounds to me that you would really have to make the building one your hobby. How much time do you think one would have to put into it, making things work? True, I did put a lot of time and effort into it, but also I have a lot of IoT applications at home. And yeah, a hobby, yeah, okay. If you want IoT at home, indeed, I'm just reading the questions as I.
But maybe Jeroen, you can answer the question for Max a bit when you explain one of your projects, and then you can see
maybe
time you take in it, and then you have a bit more of a view.
Yeah, and Sophie's right actually. So if you just follow a tutorial, you can get a project up and running in a couple of hours or maybe minutes even. If depends on how big the project is. I don't mean it as a criticism. I was not offended. Thank you, Max. But indeed, yeah, for me it's my hobby. I do believe that if you just you have people renovating their own houses as well, I would not call that a hobby. I would call it a hobby for maybe 1 year when they really work intensively in the house, and you can do that that way for an IoT solution as well. If you want to IoTize your home, you can just do it for 1 year, come up with a lot of projects, really deepen yourself in the knowledge needed to accomplish those projects, and then do it in a year, and then afterwards it's not your hobby anymore. And for that year, you are really obsessed with IoT then. So you can look at it that way. So yeah, it does require a lot of time and effort to build it yourself, but it depends on the project. Okay, enough about that. What is a Raspberry Pi exactly? Why do I mention Raspberry Pi? Because it was shown on the slide before. If you want to build your own projects, mostly for beginners, you would use a Raspberry Pi because that's the one that resembles a normal computer the most. It is a single board microcomputer. It is small. It is low cost, even though it is still a bit pricey. I believe the Raspberry Pi 4B goes for around 60 euros. I'm not even sure. But then you also have to buy an SD card, a power adapter, maybe some heat sinks. So there's a lot of stuff not mentioned on the price tag alone. It has GPIO pins, and those pins are used to control input and output devices. So you see the little pins there on the top of the controller. Those are the GPIO pins. It's called general purpose input and output pins, by the way. And it's got a Debian-based OS. So Debian is a Linux distribution. So it's got a Linux operating system at its core. On Amazon, the Pi 4 goes for 58 euros. So almost right. Yeah. So it has a Linux operating system, which means that it basically is it is a computer. It is a fully fledged computer. It is small, so it has limited memory and processing power. But I always give this example. If you go to your grandma's house and you replace her desktop computer with a Raspberry Pi while she is not looking, she would not know the difference, except that she would probably have been using a Windows instead of a Linux. But it is a computer. You can do everything with it that you can do with a normal computer. It has an operating system. You can run normal application on it. You can run a desktop interface on it. I even use it at home to watch, how's it called, streaming TV, TV via the browser. So we watch me and my wife, we watch a program together, but we don't have a TV subscription. So we always look via the browser, via websites that offer those programs for delayed viewing, and we use a Raspberry Pi for that, and it works because it's just a computer. Next, we also have Arduino, another very popular controller, and here we say that this one is a single board microcontroller. So the Raspberry Pi is a computer, while the Arduino is a controller. What's the difference? Well, a controller is dedicated to one single task, whereas a computer has an entire operating system with different processes and different tasks within it. So that's the big difference. It is also small. It is even lower cost than a Raspberry Pi. I don't really have an idea how much the Arduino Uno costs, but you have an ASP, for example, that's also an Arduino, an ASP 32, for example. I bought one of those at Alibaba or another Chinese website for 2 euros or something, including the shipping costs, so it's very cheap.
39 euros on Amazon, says Max.
Yeah, that's the Arduino Uno. Yeah, thanks.
And someone else says I found it for 23.
Yeah, that's probably on some Chinese website. Yeah. It also has GPIO pins, and you program it with a C++ dialect. So it is it is dedicated to one programming language, dedicated to one application, and even one process that is running all the time. Another poll that I would like to throw into the group here: which development boards have you used before? So normally, if you scan the code, you can type in your Penny scanning. I'm curious what she will type.
I can't type anything.
So somebody already used an Arduino Uno. There's a lot of people who also did not use it before. Raspberry Pi, most of the people. What else is there? ASP, Node MCU. Yes, VT Cloud. I don't know VT Cloud actually. I really like the strip laptop motherboards strapped to a screen with tape. Okay, nice. So we see that the Raspberry Pi and the Arduino are clearly the winners here, but there's other options as well. I'm gonna have a look at the Witty Cloud, and I'm curious about that after the presentation. I/O components. So first we have the input components, and here's a few examples on the slide. On the left, in the left upper corner, we have a PIR sensor, a passive infrared sensor. Then on the bottom left, we have a switch. So it can take two states, and based on that, it connects or disconnects a circuit that is connected to it.
Jeroen? Yeah,
yes.
Patrick is saying something. The strip motherboard, yeah, is
3 years before it frees to boot. That's 3 good years that lasted then, yeah. Yeah, where was I? The passive infrared sensor. It's mostly used to detect movement because it measures the amount of infrared light that is absorbed by the sensor. Then the next one is a ultrasonic distance sensor, and based on ultrasonic sound waves, it detects the distance between itself and an object. So it sends out ultrasonic waves, and those waves, they get deflected back by the object, and based on the time between the sending and receiving of the waves, the sensor can calculate the distance between the object and the sensor itself. So it has to know the speed of sound, etc. So it's quite cool, and you see that in the world of IoT, there's also sometimes physics going on, like now with the ultrasonic waves and with the infrared waves and etc. Then we have a push button, very simple. Also can connect and disconnect a circuit that is attached to it. And then the last one is a temperature sensor. It can also measure humidity, and yeah, that's it basically. Nothing more to say about that. Output components, also a few examples here. A little light emitting diode or LED light on the left. Then we have a relay module. Relay modules are mostly used to switch high voltage circuits. So if you want to switch the lights in your home, they're mostly attached to the AC mains voltage. So if you want to switch those, you need a relay module because the voltage is way too high to directly connect to a controller board. The next one is a numeric display, so it can display numerals, so numbers, or even alphabetic characters if you are a bit creative. And then the last one is a zoomer, a buzzer, buzzer module. So it can buzz on command. You have an input pin, a voltage pin, and a ground pin. So the voltage and the ground are always the same because you need some power to circulate through it in order for it to be able to operate. And then the input pin is used to send the control signals. So when you send, for example, a 1 on that input, it's not that simple, but just imagine that you can send a 1 to the input pin for the buzzer to go on, and then a 0 for the buzzer to go off. It kind of works that way. So that is the control logic, and the other two are for powering on the buzzer module. Then next to that, next to input and output components, there's also some intermediary components that you need to use. The first one are resistors. Is that the right word in English? I think so. If it's not, please correct me in the chat. So those are resistors. Yes, it is. Okay, thank you. those are resistors. They're mostly used to to compensate for the effects of Ohm's law. So Ohm's law, if you don't know it, look it up after the presentation. It tells us the connection between voltage, amperage, or current, voltage, current, and the resistance in a network. And these resistors, they can influence the resistance in a network. So that way we can control the voltage or the current within a circuit. The middle one is a breadboard that's mostly used to prototype products. So you see those little holes in the board that's used to connect components together. So one row is connected to each other, and another row is not connected to the first row, but it is to the holes that are in it. So that way you can connect certain components with each other and not connect other components with each other that are not supposed to be connected, etc. So it's really easy to switch those circuits up, and that's why it's mostly used for prototyping. And the wires that you use for prototyping are displayed on the right. So those are called jumper wires. Yeah, that's it basically about this. Software. So a little more information about programming languages that you can use. So on the Raspberry Pi, you can use, or I have used Bash. I've used Python as well. I've even used Java, and I do believe it's installed by default on Raspbian. And you can basically choose whatever programming language you want, because it is a fully fledged computer, and on a computer you can basically use any programming language as long as you install the right compilers and environments, etc. Next, we have an Arduino. Well, there we do have the requirement that we need to program our programs in a C++ dialect. So it is not C++ entirely, but it's really resembles it quite a lot, and that's why they always refer to it as a C++ dialect. You also have PyCom, so that's another controller that you can use. We actually have some of those in the lab here, well, at the heart of it, it's basically an Arduino-like controller. I believe it's an ASP of some kind. The firmware that is flashed on it requires your programs to be written in MicroPython. MicroPython is a bit different from regular Python. I'll spare you the details. Then we also have reduced font size. The difference between Python and MicroPython, you mean? Okay, sorry. Then we also have Espruino, also based on an ASP module, I think. And there, as you might have guessed it, it's JavaScript at the heart. So you write all of your programs in JavaScript. Quite cool, actually, because I have bought one of those projects from the Espruino guys via Kickstarter. It's a smartwatch that you can fully program yourself with Bluetooth connectivity, and it's really awesome to experiment with that as well. Yeah, environments for Raspberry Pi. The first example that I have here is ... because, as I said before, it's an operating system. You can choose whatever environment you want. If you want just to start programming bare bones and run it in the command line, yeah, feel free to do it. If you want another environment, yeah, you're basically free to use any environment you want that is able to run on the Raspberry Pi architecture. Next, Docker is also a possibility, and a possibility that I like to use quite a lot because it is very handy to use when you want to share your programs that you've built, when you want your programs to be securely closed off from the Raspberry Pi environment itself. You should look it up when you have the time. It's basically some form of virtualization, but it's way more efficient than virtual machines, etc. And by the way, if you start working somewhere within a few years in a company, 9 chances out of 10 they're already working with Docker. It's very popular in professional environments these days. And lastly, we have Arduino. And I've depicted the circle of life there, so which means that it basically is stuck in a process loop all the time, always executing the same process over and over again, and that's actually what an Arduino does, and that's why it's called a controller. It can only execute one process at a time, and that process is always in a loop. Okay, another poll. Just to get to know you guys. What's your experience with Docker? Because I mentioned that it's quite popular in the professional world. I'm curious how it is with students. Okay, so a lot of people heard of it, but never used it before. A few use it frequently. Okay, what's a Docker? Okay, yeah. So a lot of people also never heard of it. Okay, I'm not going into much detail now about it, but I suggest that you read yourself up about it if you have the time after these presentations or in the coming weeks or months, because if you can mention it in your job interview, that well, all companies use it, so it's will definitely come in handy. I hear someone through the mic. Is there something?
Oh, Jeroen, I wanted to just say that it's maybe good to high level explain Docker
Okay.
a bit more, maybe, because a lot of people still, a lot of people don't use it or never heard of it. So
okay,
can explain a bit.
Yeah.
If that's
So,
okay for everyone, can be interesting, I think.
So I'll just begin with saying that Docker has very clear documentation. So if you ever want to know more about it, just Google it and you will find the official Docker website where it has a lot of tutorials and explanations about it. I also learned it from scratch via the website. Is Docker only used in projects with hardware? No, it is not. It is actually mostly used in projects with software. That's actually where I use it the most. Docker works with containers. That's why they call it containerized environments. So when you want to run an application, you can choose to run it in Docker. If you can either write your own application and put it in a container, or you can fetch some container file from the internet and then run that container locally in your environment. Now, what is a container? It is a containerized environment, so a closed-off environment from the host system, from the Raspberry Pi in this case. So it is more secure than a virtual machine, more efficient because it doesn't need to run the entire operating system within the container. It only runs that specific application, so the memory usage is really minimal. And it's also only one application. What else is there to say about Docker? It works with Docker files. So when you want to share your Docker container, you don't share the entire container. You just share a file, and in that file, it is defined what base image you use and which installations you do on that image. And based on that, you have the full specification of the container. So, for example, if you want to run a torrent client in a Docker container, you can say in the Docker file that you want to start from an empty Linux Alpine environment image, then you want to install that torrent client and you're done. That's 2 lines in your Docker file, and based on that, Docker knows how to run the container. It spins it up, and the container is running. You can also share ports from the container between the container and the host, so that you can actually accept incoming requests or something like that. And that's it basically. And now I'm going to look at the question that was asked. Do you also use it to SSH into your, or do you use it as an environment on the Pi itself? I don't use it for SSH sessions. I think that's a bit overkill because yeah, the Raspberry Pi just has an SSH daemon running on it. What do I use it for? I use it for the torrent client example. I use it to run websites on. So my websites, they each have their individual containers, so that whenever there is a breach, there is only a breach within that container, a security breach, I mean. So it's, yeah, it is still an issue, of course, but it's not that big of an issue because I know that the rest of my environment and the rest of my containers are safe. It's mostly out of security concerns that I do it, and because it's just fun to learn Docker. You're welcome. Okay, next one.
What's that question? Jeroen?
Yeah. No, I already answered that last.
Okay, sorry. It was I was with a delay.
But only run Docker instances on it. Therefore, it seems redundant. Do you have any tips? Yeah, I don't know about the footprint of Ubuntu, but why don't you just use the default Raspbian operating system? It also works with Docker. Sometimes it's also easier. Installing database can be difficult with Docker. Yeah, that's true. Yeah, it's a lot easier to just run applications. You can just fetch the Docker file from the cloud and run it out of the box. Yeah. Okay, I'm gonna continue with the presentation. If there's more questions, I will see them in the chat. So networking. You already know Wi-Fi and BLE. BLE stands for Bluetooth Low Energy. So those are the most common technologies used today in consumer products. But in the IoT world, we also have some others. We have LoRa, Sigfox, and narrowband IoT. So those are some popular technologies that are also used in the IoT world. Why? Well, it's because LoRa, for example, has a much smaller bandwidth, but a larger radius. So I can send a LoRa message to another LoRa receiver that is a couple of kilometers away, and I cannot do that with Wi-Fi. So that's the reason why we need those type of networks, because sometimes we just don't have Wi-Fi in a neighborhood and we need to communicate from a long distance. So that's it about networks projects. So I'm gonna quickly go over those. Someone had to leave. Okay.
Yeah, it's okay. Joris said that he left.
Okay. What I've built, a garage door controller. What did I use for that? I use an ESP32. It has Wi-Fi connectivity. That's why I use that one. I combined it with a relay module. So I created a parallel circuit together with the switch that was already on my wall for the garage door. And that way I can now control the garage door with both the switch on the wall and with my cell phone that is then connected to a web server that sends its requests, to the little ESP that is connected to the garage door itself. Share the link again for feedback. Okay, next project.
Sorry.
No problem. Photo booth. this is actually a kind of out-of-the-box project, except for the hardware stuff. So PyBoot is an open source initiative to transform your Raspberry Pi into a photo booth. So I've used that code to put on a Raspberry Pi. I use the camera module, relay module, display, and so those big arcade buttons that shine up when you press them or don't press them. You see an image of my own photo booth there on the left, and that's it basically. Another project that I built is a water level monitor. So my dad has a well in his garden, and well, mostly he just fills it up with water each day or each week without even knowing if he is overfilling it or not, just to make sure that he still has water inside. So he has no idea how much water is in the well, and that's why each time he fills it up, not knowing if it overflows or not. So that's really inefficient, and that's why I've made this so water level monitor to monitor the water level inside the well. We need two controllers for that, one controller inside the well and the other one inside the house. The one controller is connected to a distance sensor to monitor the distance from the controller to the water inside the well, and the other is connected to a numeric display to display the actual distance that is measured inside the well. What kind of control methods do you use? PID. What does PID stand for? Process ID? No.
So it's proportional integration differential. So it's like how you deal with the differences in your signal. So you want to have a certain, like, you want to reach a certain threshold, and then you have an error, and how you deal with that error. If you use PID for that. Or you just
wait, can you repeat the first part for, with the signal?
So you have a certain goal you want to achieve, and you have an error because you measure like how close am I to that goal, and how you deal with that error is you can use like different methods to compensate for that error. And I think one of the most conventional ones is PID.
And is it specifically about this project that you ask about it?
I'm just wondering if you were thinking about like using different kinds of controllers for that, because that's also called controlling, but that's more like low level. So I was wondering how you are dealing with that, or you just use like a default.
But just so I understand correctly, is it about dealing with the error of maybe measuring the wrong distance, or is it something else that you mean?
So it's the error. So sometimes you need to have like more signal to compensate for that error, and if you determine that with PID. Okay, maybe it's more low-level question that I should ask another time.
Yeah, sorry, I don't completely understand the question. Sorry.
Well, I don't want to take all the time, but I was just wondering if you were busy with control theory and stuff. But okay.
No, not at all. Actually, no. I don't believe I ever encountered such problems. But it has something to do with signal strength and. If you send data and you don't know if it will be received or not based on the signal strength being too low or something like that.
No, not really, but I'll ask you another time.
Yeah, maybe let's discuss it after your presentation if there's more time.
Yeah, thanks.
Yeah. Okay, different project then. Sonos doorbell. I haven't actually built this entirely myself, so this is a screenshot from a project from Hackster.io. I am busy with it, building it, so I already built a Sonos controller that is a bridge between the OAuth2 API from Sonos and my own Sonos API for controlling my local Sonos speakers. What is still left to do is actually build the doorbell itself. I have to lay down some extra electricity lines for that, so that's why it's put on hold for now. But it's a cool project. You don't need a lot of stuff for it, and it's quite easy to do actually. So then what you can build, I've researched a few projects that are quite very entry level for beginners. So first is an arcade station. Functionality, you can play retro arcade games on it. What do you need? You need a Raspberry Pi and a USB arcade controller. And what else? You need the RetroPie software. So it's software that transforms your Raspberry Pi out of the box into an arcade station. So you really don't need more than this. Next one is a security system. It is responsible for video surveillance with motion detection. What do you need for that? Also a Raspberry Pi and an IP camera, or you can use the Raspberry Pi's camera module for that. What else? You can use MotionEye OS, and that one, that application transforms your Raspberry Pi into a video surveillance system, and it also supports motion detection. So again, there's not really a lot of stuff for you to actually tinker with. It works kind of out of the box, but it's still fun to actually build the project and have something accomplished at the end. The last one is a private cloud. So a privately hosted cloud storage. What you need, Raspberry Pi again, and a hard disk drive. What software should you use? Well, probably Nextcloud. I've done some research, and that's, according to me, one of the best options out there. It's also free, and that's one project that I will also have to start on quite soon, because I've seen, I don't know if fantastic piece of software. Okay, thanks. So I don't know if some of you also have cloud storage with TransIP, but I recently got a message that my storage will be deleted. I was one of the first to jump on it when they handed out free storage, and now they've stopped. Really pissed off about it, and me too. So I will have to do this project. I don't have a choice. What else is there? There's Google AIY. AIY stands for Artificial Intelligence Yourself, so it's a wordplay on DIY. On the one hand, you have a smart camera with image recognition using neural networks. On the other side, you have voice recognition with the Google Assistant on the smart speaker. So those are two projects that Google offers. You can buy them from their website. I believe they also ship to Europe. I'm not quite sure. I haven't ordered myself. But so those are really low-level entry projects, a bit more complicated than the ones I mentioned before, though. So if you really want a challenge, I recommend these ones. A bit more expensive, though. I believe it's around 70, 80 euros or something. But you do have a fully working project in the end. So maybe skip the poll because it's already after 1, and I'm just gonna go to the getting started because I see people already leaving. How can you get started yourself? Well, there's a lot of starter kits available for the Raspberry Pi as well for the Arduino. Tutorials. I believe you guys are technical on the software side, so programming might not be that relevant for you guys, but electronics, in particularly, for the software side, Docker. So I see that not a lot of people have knowledge about Docker, so that it would be good to build up that knowledge during these projects, because afterwards in the industry, in your working life, you'll probably need some knowledge about Docker. Then some entry-level projects. I've mentioned a few in the slides, but there's also some websites where you can find beautiful projects for beginners. Some good ones are Hexer.io, Pi My Life Up. That's only for Raspberry Pi project though. Instructables. I believe those projects can be a bit more complicated when you look for them. And then the last one, create.arduino.cc. The project hub is, of course, only for Arduino projects. Okay, and now it's time for the Q&A. This is a code that you can scan, and I believe, where can I find the answers? I have to log in. So maybe just ask your questions in the chat, sorry. I don't know if they're gonna be displayed here, so just ask them in the chat if that's okay with you guys. So general questions about the presentation or about anything else, and if you have any ideas about projects that you want to implement yourself and have technical questions about those, please do ask them here. There's, okay, it works. Yeah, you can do it via the Slido plugin then, if you want. You can choose. What do you think is a very easy starting project that almost everyone could use? Yeah, I would have to go back to the slides. You know, I remember the projects. RetroPie, security system, and the private. I would say the private cloud. I think everyone could use that, a private cloud. Everyone uses the cloud. I'm quite sure of that. Either it's Google or Amazon or Microsoft. I'm quite sure that everyone uses some kind of cloud. I also do believe that it's better to own your own data instead of big companies owning your data. So in that sense, private cloud would be the most useful project, and it's also quite easy to set up. What is your opinion on private cloud solutions like Synology NAS? I actually I have a NAS at home. I don't really. Yeah, I do use it as a cloud, but only as my media cloud. So not as I don't have any documents on it. I don't have any experience with Synology actually, so I don't know what their data policies. Are they allowed to share your data with the company itself? Does it purely stay within your network? I would say yes. Go for it, Synology, if it doesn't do weird stuff with your data, because it supports a lot of applications on it as well, as I understand it. I've seen some examples of torrent clients on it, and even applications like Radar or Sonar hosted on a Synology. So another question here. Am I missing questions or because there are 6? Okay. Okay. What is one home automation that you cannot live without anymore? Yeah, that's the examples that I didn't show in the slides, because last time I had the feedback that I showed too many projects. So the automation that I cannot live without is the Raspberry Pis that are responsible for my media management. I have an entire media library that automatically downloads the correct movies and TV shows at the right times and copies them over to my NAS. It syncs my Kodi library, which is a media player, which is installed both on my TV upstairs and downstairs. It connects to the same database so that whenever you start playing a movie upstairs and you pause it, you can continue it downstairs. So that's really cool. So my entire media setup, I cannot live without actually. Yeah. What kind of processing power does Raspberry Pi possess for very standard tasks like Word, browsing, Excel, etc.? Well, the Raspberry Pi 4 is actually quite powerful. Let's see, I think you have a version with 2 gigabytes RAM, one with 4 and one with 8. Although I believe I've read somewhere that you can only allocate a maximum of 1 gigabyte per process. So you should be aware of that. And the processor itself, I cannot say a lot about it. I know it's more powerful than the Raspberry Pi 3. I mentioned before that I also do some live streaming via the browser on such a Raspberry Pi to watch TV shows, streaming TV shows. So it's quite powerful for the things I do. Word, browsing, Excel, sure, yeah, you can do those. Next question. What is your most favorite and enjoyable project that you have ever worked on? Interesting. I have the habit of forgetting a lot of stuff, so I would say that the project that I am working on now, the Sonos project, that's a really challenging one because it's got a lot of components. It's got well, I have to make the connection with the Sonos API, and the Sonos API, I really love it because it's very secure. It works based on OAuth 2. But I had to make a bridge between that security and my own, because I cannot always. It's based on tokens that are only alive during a certain period. I believe it's 24 hours, and then you have to request a new token. So I had to write my own API in between that automatically refreshes those tokens, and then I call my API that calls the Sonos API via my own security measures locally. And then, yeah, the other part of that project is the doorbell. So that's also one big project that's still lying ahead of me. So it's a really fun project that really touches upon all the aspects of IoT. So that's nice. That's it for now for the questions. It's nice that there.
That was the last question. Yeah, there's a lot of interest from the people, so that's very nice. But I think it's nice if we also wrap it up here, because it's been quite some time, and I think a lot of people also have to leave. So yeah, I would like to thank you very much for giving the talk today. I thought it was really interesting, and you gave us a lot of information to get started with such projects on our own. So that's really nice. And for those of you who are still here, thank you for sticking out until the end. And have a nice day.